In this recording, we're going to learn about the tangent function. So we've learned quite a bit about sine and cosine because they're the most important functions, but there's also tangent. Remember, SOHCAHTOA also had tangent, and you remember tangent was defined as opposite over adjacent. So that's still true. And take a moment right now, if you would, to solve for the sine, cosine, and tangent of theta for each of these angles below. Play the recording when you're ready. Okay, so hopefully you do a little Pythagorizing and find out this side is a 3. You do your Pythagorean theorem. Again, when you do your Pythagorean theorem on this one, it's going to work out that this side is a square root of 3. So then we should be able to find the sine, cosine, and tangent. And hopefully you recognize this triangle is really one of our special triangles. It's just been scaled by a scale factor of 2, right? So really you should be able to guess that this angle right here is a 60-degree angle. In terms of on the unit circle, we had sine is the y-coordinate, cosine is the x-coordinate. Oh, where does that leave tangent? Well, look at this in terms of x and y. If tangent is the opposite over the adjacent, I want you to write here something about tangent in terms of x's and y's. So take a moment to think about it and write it down. Because hopefully you said it's the y of x. Try that again. It's the y over the x. It's the opposite over the adjacent. Now, in terms of defining this in terms of sine and cosine, well, we had said y was the sine and cosine was the x on the unit circle, right? So this is another way to define tangent in terms of if we know sine and we know cosine, it's the ratio of those two measures. Okay, so there's our definition of sine and cosine. It's also the y over the x. That's an important thing to know on the unit circle. Okay. And you might say, well, Mr. C, isn't it always going to be the y over the x? Because on the unit circle, the radius is 1, but on any circle, the radius doesn't come up here. And you'd be exactly right. It's just the y over the x. At this point, I'd like us to look at a gizmo that does a nice job of demonstrating the tangent function. Okay, so this comes from explorelearning.com, and if you have access to Explore Learning, there's the URL right there, explorelearning.com, and the gizmo is called tangent function. Go figure, right? You have access to this, right? You can either just go to this web page and use the 5-minute that's free, or you could log in. You have a username and password that you created, and you wrote on your orange salmon-colored sheet. Okay, so first off, let's check out at some key angles. So on the other page here, it asks us for the tangent of 60 degrees and 45 and 150, 180. Let's check that out. So here at 0 degrees, the tangent is, well, 0, because it's the y over the x. And if I look at those two coordinates, it's the it's the y, which is 0, over the 1. So now let's move to 30 degrees. Tangent is square root of 3 over 3. If I move to 45 degrees, well, the x and the y are the same. So when I divide y by x, I get 1. So let's go ahead and put that answer in here. And then our second question was about 60 degrees. So at 60 degrees, the tangent is square root of 3 over 2 divided by half, and that simplifies to just be square root of 3. We can go ahead and put that in. Nice. And now as I continue up here, here's where it gets a little hairy. I'm going to turn off common angles only and get very close to 90 degrees. Notice how sine and cosine never got above 1, but tangent can, because we're dividing a number that's very close to 1 by a number that's very close to 0, right? And I can get really close. The closest it'll let me get here is 89, I think. right? So tangent is all the way up to 57, right? If I could go 89.99, this would get even bigger. In fact, it'll get as big as you want. But as soon as I get to 90, that's where it causes a problem, right? I'm going to put it back to common angles only. It's undefined. And think about why that is. Okay? Why would that be undefined? Think about the definition of tangent we just developed. You've got a y value of 1 and an x value of 0. So of course that would be undefined. You're dividing by 0, right? And again, that reference triangle, I really like this. The reference triangle is going from a very wide short triangle where the y is small and the x is big to one where the y is tall and the x is small, up to the point where there's no x at all, and then it's undefined. Okay, so to finish this out, tangent of 150, well, that would be over in quadrant 2. So 150 has a negative. Remember, all students take calculus. So the sine is only positive in quadrant 2. The tangent is negative. So negative square root of 3 over 3. Is it bothering you that this is purple and the other ones are green? I'm not sure why it came out that way. Finally, 180 degrees. Well, just think about what that is before I drag this purple dot over here. What are the coordinates of that point? And therefore, what is the tangent of that angle? Okay, the point's coordinates are negative 1, 0. So we're dividing the y by the x. So that should be a 0. And of course, there is the tangent value over here. There it is up top. Okay, so we just talked about places where the tangent function is undefined. So what is the sine and cosine of 90 degrees? And then why would that be undefined? Take a moment to answer those yourself, because we've already kind of alluded to those. And I'll leave this up here while you think. Okay, so hopefully you paused and thought about why it is undefined at 90 degrees. So the sine of 90 degrees, or pi over 2. So those would come out sine of 90, well, that's a 1. Cosine of 90, that's a 0. So when I divide 1 by 0, 1 over 0 is undefined. Okay? So which one of these would be an angle that gives a tangent that's undefined? So you've got your paper with those choices. Let's check out this unit circle and just think about, again, what would cause us to be undefined on this unit circle. So hopefully you realized it has to be a place where we're dividing by 0. So that would be either at this place right here or this place right here, depending on the amount of times they go around and the direction. Those could be named differently. And of our choices, the only one that makes sense is this one right here. So 270 degrees, I can bring that down here. Of course, it is undefined. Okay, so let's just check out the graph for a second here. The graph of this, we can show curve. We're going to put it into radians. That's what the curve looks like. And it looks pretty crazy. You haven't seen a curve quite like that, but it sort of makes sense. As this moves along, let's put it back here. As this moves to 30 degrees, 45 degrees, 60 degrees, and as it gets close to 90, it starts moving way up the graph to the point where it's off the graph. And then when it gets all the way up to 90, it is at an asymptote. That's what this dotted line is. Okay, so the curve approaches the asymptote. I can drag this way up here. The curve gets really close to the asymptote, but it never really reaches 90 degrees, because at 90 degrees we're dividing by 0, so it's undefined. Okay? And it is periodic, but it's not a sinusoid. It doesn't have that wave-like pattern. It also has a period that's only pi, right? The shortest repeating distance is pi. It goes from negative pi over 2 to pi over 2. So let's just put that sketch in our notes, probably up at the top here. Not sure why that little purple came up. I wasn't trying to do that, just how it came out. Let's draw in the dotted lines for the asymptotes. And then let's draw the curve. So the curve gets close to the asymptote. And then something like that. And we will say the period is not P times B equals, I guess I would say something P times B, it keeps coming up with that purple, P times B equals pi in this case for a tangent. Okay, so it's different than 2 pi, which was the truth for the sine and the cosine function. Thanks for watching.